What we're going to do in this vodcast is take a look at Thomson's experiment and Rutherford's experiment. If you remember from class, J.J. Thomson is given credit for discovering the electron, and Ernest Rutherford is given credit for coming up with the structure of the atom. We'll go over the basics of the experiments and what you should know, say, for an exam. So let's take a look at Thomson's experiment first. What J.J. Thomson did was he took what we call a cathode ray tube, and basically a cathode ray tube is the tube that you would see in an old-style television and an old-style computer screen. What Thomson did was he evacuated the tube and he created what we call a vacuum. So he took everything out of the tube, including the air. What this did was it allowed Thomson to experiment with different atoms. There's a couple things you want to know about the cathode ray tube. At this end is the negative side, and then at this end is the positive side. Thomson also had some magnetic plates, so he could adjust the electron beam that was going through the tube. And then at the end of the tube on this side, he had a screen to see where the beam would end up. What Thomson would do then is put a charge through the negative plate there, and the circuit would be completed on the positive side. So Thomson filled the vacuum tube with different gases. So let's just say, for example, he started with neon. What he would do is turn the switch on, and a beam would go from the negative side past the positive side and then hit the plate on the end. So the first important thing to understand is that it always traveled from negative to positive, and this told Thomson something. What Thomson would do then is adjust these magnetic plates, and again, let's say that's the positive side. If he turned the magnetic plates on, what would happen is the beam would bend towards the positive side and away from the negative side. The second thing that Thomson did was he tried different gases inside the tube. So let's say he used neon for one experiment. He may have used krypton for another experiment. And what Thomson realized was that no matter what gas he tried inside the vacuum tube, the beam did the same thing. So what we want to do is come up with two results from Thomson's experiments. Since the beam always went from negative to positive, Thomson knew that opposites attracted and like charges repelled, so he knew whatever that beam was, that it was negative, since it went away from the negative side and towards the positive side. Since the beam did the same thing with every gas that he tried, he knew that whatever was causing this beam had to be in every atom. So it was what he called, or what we call, a fundamental particle. In other words, the beam had to be made up of something that was in every atom. So essentially, Thomson discovers that the fundamental particle is the electron, and that electron is negative. Alright, let's take a look at Rutherford's gold foil experiment. And again, if you remember from class, there are three things that Rutherford noticed about the gold foil experiment. So we have 1, 2, 3. And those three observations led to three conclusions about the atom that we want to talk about. A couple things that are important about Rutherford's experiment. First of all, he used a radioactive source, and that radioactive source emitted alpha particles. And there's two things about alpha particles that were important. They're positively charged, and they're very dense. And this is important because that led to some conclusions about the experiment. So what Rutherford did was he took this alpha source and he fired it at a sheet of gold foil. And he noticed three things. Most of the particles, as you can see, went right through the gold foil and hit the screen on the back. So as these alpha particles are firing towards the gold foil, most of them are going straight through the gold foil and hitting the screen on the back. The second thing that he noticed was some of those particles were deflected. In other words, as they would go towards the screen, they might go off to the side, as you can see from that beam and that beam. This told Thomson something, or this told Rutherford also something. The third thing that he noticed back, or the third thing that Rutherford noticed, was every once in a while one of the beams would deflect straight back. In other words, it would come straight back at him. And this also told Rutherford something. There was a quote where he says that it was like firing a cannonball at a piece of paper and having the cannonball come straight back at you. Let's take a look at the three items and then talk about, or the three pieces of evidence and what that meant. Since most of the particles went straight through the gold foil, this would be the same as if you shot all these particles and these were all atoms. If all of these particles are going straight through those atoms, it means that most of the atom has to be empty space. So looking back at our three conclusions, the first thing is that most of the atom is empty space. If there were all kinds of, looking back at our atoms, if there were all kinds of things inside the atom, as those beams went through, they would have ricocheted or deflected. But since they went straight through, it told Rutherford that the atom was mostly empty space. The second piece of evidence that the alpha particles would sometimes deflect off to the side, since Rutherford knew that alpha particles were positive, what he assumed was every once in a while, whatever was at the center of the atom, that alpha particle had to be going near it and deflecting away from it. So if alpha particles are positive, whatever is at the center of the atom, what we now call the nucleus, had to also be positive. The third piece of evidence where the alpha particle deflected straight back at the alpha source, Rutherford knew that since the alpha particles were very dense, whatever the particle was hitting, in other words, every once in a while that alpha particle would be going at the atom, would hit the atom and ricochet right back. If that alpha particle is very dense, whatever it's hitting has to be also very dense. So the nucleus has to be very dense. So Rutherford noticed three things about the atom. That the atom is mostly empty space. There's a dense positive nucleus at the center. And that brought in the not what we call the modern structure now, but the modern structure back then of the atom. Nucleus at the center, being positively charged, and electrons way outside. So just going back to review quick. Thomson discovers the electron. He discovers it's a fundamental particle with a negative charge because in the vacuum tube, the beam always went from negative to positive, and it worked with every gas that he tried. Rutherford discovers the structure of the atom by noticing most of the alpha particles go straight through the gold foil. Some of them are deflected, and some of them are shot straight back at him, telling him the atom is mostly empty space, the nucleus is positive, and the nucleus has to be very dense. If you have questions about any of these vodcasts, there's going to be a forum set up on the Moodle site. Visit the forum and ask your questions.